Okay, hello, welcome. Welcome to session 4. And my name is Kristen Welch. I am the PTN facilitator from Los Angeles Unified, and it is my privilege to introduce my friend and colleague from UCLA Math Project and a fabulous thought partner and mother, Christine Quinny Allen. So I'll pass it on to you.
I'll jump right in. Welcome, everyone. So today we're going to really dive into the power of the student invented model and like the teacher's role in bridging from concrete to abstract. We're just going to scrape the surface, but I do want to create a lens for us. So first, we're going to do the math that we're going to look at because we can't look at student work without having done math first, right? So let's solve this story. Todd has 6 bags of M&Ms and each bag has 43 M&Ms in it. How many M&Ms does Todd have? So let's take just about 1 minute, solve it for ourselves. If you solve it already, you can throw in the chat some numbers, symbols, words that explain how you solved it. And then we'll come back together. Someone's hungry. Oh, nice, Liz. Liz is thinking about 6 groups of 40 and 6 groups of 3. Amy is 2, but she's notating it with some mathematical symbols. Nice, Evelyn, thank you. Blair's also thinking about decomposing this 40 and 3. Nice. I wish I could dive deep into y'all's strategies because I feel like that's some of the magic that we do in CGI is thinking about our own thinking as mathematicians. But we are going to dive into some student work here around this problem. Before we do that, I want to give you guys a lens, all right? This is called the professional noticing protocol. And this is something that we as teachers use to really carefully look at student work, all right? It comes from research out of Vicki Jacobs and some other friends who wrote the Extending Children's Mathematics book. So I call it the ABCs of professional noticing. So first, we really attend to the details of what kids are doing in order to make sense of it, right? And then we want to explain our interpretation. Like, what do we think that we're understanding from this mathematician? What do we think they know? And then we want to think about next steps, right? We want to think about that piece in, where's the depth? Where do we want to take this kid next? What are we wondering about? And based on their feedback, we'll offer them something, right? So together, we're going to do these ABCs. Oh my gosh, Critty, I just realized I didn't redo the Jamboard. Nice. All right, so what I'm going to do is I'm going to put a Jamboard link in the chat for you guys. And you're actually going to do A, B, and C on the Jamboard directly. All right, just give me 1 second. And then we'll do a bit of a gallery walk based on what we kind of see and learn from one another. And remember this idea around teacher role in admiring our student invented strategies, but then also thinking about kind of bridging this concrete to abstract. So let me put the link in the chat. I'm also, so if you guys would stay on number 1, number 1, that would be perfect. Oh, Critty, you're awesome. So I'll share my screen here for us too. We can kind of see it all happening live. We have Alexis. She's our student today. And so we're first going to describe the details of what we think the child did. So let's start there. You guys can go ahead and dive in and edit the Jamboard as you'd please. Add Post-it notes. You can add text boxes, whatever you'd like. Nice. We're noticing this use of tally marks, right? Yeah. Someone's naming that they see the story represented here, right? She drew 6 bags of M&Ms, right? That's the story. And there are 43 in each bag. Ooh, someone's noticing that she's circling groups. Direct modeling. I can see and touch each M&M, right? The definition of direct modeling would be that the story is represented there, and then it follows the action of the story, right? There are 6 bags of M&Ms and 43 in each. And this is direct modeling by ones because each of the M&M is represented there as one M&M. Yeah, she circled 40 and left 3 kind of outside the circle, right? There's a group of 40 circled and then 3 outside the circle. And it looks like she has groups of 5. And I'm going to press on this idea of interpretation, right? Which is going to come next. So we're not quite sure what she did with those groups of 5. It's not clear here if she counted by 5s or how she counted. We don't have any evidence of that on the paper. But I know that maybe not everyone got a chance, but we're going to move here together to B. All right. So based on what we see in the details, how can we explain what we've learned about this mathematician based only on the details we saw, right? We haven't talked to Alexis yet, and unfortunately we can't talk to her today together, but what interpretations can we make about this mathematician? And I also want to notice a name that you guys could unmute yourselves if you wanted, but you guys are doing good on the Jamboard too, so it's up to you. Yeah, Atu says she attends to the story. Yep. The student understands that there's power in the story, right? And uses the story to solve. She's decomposing 43 as 40 and 3. Nice. Yeah. I'm wondering what this 5 means to her, right? Sorry, I'm already getting into questions, can't help myself, but right? She has the sense of 5. Nice. Maybe that's a friendly number. Place value understanding. What do you guys mean by place value understanding? She has groups of 40, which makes me think she understands 10s. Oh, interesting. Maybe an understanding of 10s. Understands that there are groups within groups in the story. Drop the mic right there. I'm going to want to come back to that. Gosh, you guys, we're thinking about the power of the model here. I know it's 20 minutes. Yeesh, it's so fast. But if we look carefully here, at this right here, and we think about how different it would feel to seeing the number 40 and the number 3, we see how, we see 1, 2, 3, 4, 5, 6, 7, 8 groups of 5. We see 4 groups of 10 here and 3 left over, right? There's groups within the group, which could lend itself to some really interesting mathematical ideas, possibilities of engaging our student in. All right, so let's go over to the questions, kind of my favorite part. So what questions do we have for Alexis? Gosh, what did you do first? What a nice question. And I love this question because it works anytime. Like anytime you sit with a kid, you can always say like, what did you first? Where did you start? Right? Yeah. Can you tell me about these groups of 5, right? We're really interested, I see, as a group about these groups of 5. I'm really interested in that. I'm wondering if that was how she counted really. Ooh, look at this. How did she count when she drew the tally marks? So maybe the question sounds like, how did you count to 258? Can you tell me how you counted? Can you count out loud for me? Explain how you grouped the M&Ms. Nice. So maybe we zoom in. That's a teacher strategy I've seen. Teachers zoom in on one area. Can you tell me about this square here? Or can you tell me about this circle here? Or can you tell me about these marks here, right? Getting really specific. It helps students to focus in, but it also helps us to gain insight when we have 30 kids. And maybe today I can't hear Alexis's whole strategy, but I'm really interested in what's happening in that box. Like, tell me about this box here, because it repeated itself 6 times, right? Right? How did you decide to use tally marks as your strategy, right? Like, how did you use them? Did you count with them, right? Nice. How did you get to 258, right? How did you get to the total number? How did you count them? Beautiful, beautiful. Now, what I want to press a little bit together on is this idea of bridging from concrete to abstract, right? So you guys are helping me narrow Alexis, right? Like I'm going to pretend to be Alexis a little bit. So let's say you guys are asking me about this square here, because if you notice, the square kind of repeats itself 6 times, right? So let's say we ask Alexis about this square. What's the math we might want to press on here that can bridge from this concrete 41s in groups of 5 with 3 extra to maybe an abstraction of the work that she has here? What might we ask her specifically about this? Unmute yourselves, put it in the chat. What do you guys think? Ooh, what equation can you write that matches what you drew there? So let's think together. What equations might we expect to see? Like, what might we hope to see, right? She might write 40 plus 3, maybe. Yeah, what else could she write? Ooh, she might write a collection of 5s, maybe 8 5s, right? Let's say 3, 4, 5, 6, 7, 8, and then a 3, right? My gosh, can you imagine all these 5s and then a 3, right? Or maybe it's like Rebecca said, maybe it's 10 and 10 and 10 and 10 and 10, and then a 3, right? 4 groups of 10 in addition, then a 3. What if it was not, what if the equation had 2 symbols in it? What if it was going to be 2 symbols? Like if she was thinking about like, well, I know that 2 groups of 5 makes a 10. How might we invite her to record that? 2 groups of 5 makes a 10. When we think of groups of, we think of the multiplication symbol, something that might need to be discussed in class. But if it is discussed in class, maybe it's 2 groups of 5 gets me to 10. And I might ask, how many groups of 5 do you have there? Oh, I have 2, 4, 6, 8 groups of 5. Oh, are you saying 8 groups of 2 groups of 5? Wait a minute, how much is that? Oh, that's 40. Whoa, 8 groups of 2 groups of 5, right? Nice, Evelyn, thank you. Oh, and then we have that plus 3 at the end, right? Wait a minute. It's 8 groups of 2 groups of 5 plus 3, and that gets me to 43. Did I write that correctly? Based on what she modeled, let's say in a conversation with Alexis, right? I'm not throwing this on her, I'm offering this to her. Oh, Monica, yes, because maybe that's how she counted. Maybe she's grouping 40s, right? And thinking 40 plus 40 plus 40. And maybe we'll get even more if we ask her, right? Maybe it sounds like 40 and 40 is 80, 40 and 40 is 80, right? So we might invite her to write equations around how she counted the whole, the total, right? What else? So I think here in the last few moments we have together, 8 groups of 2 groups of 5 doesn't equal 40. 8 groups of 2 groups of 5. 2 groups of 5 is 10 times 8 does not equal 40. Wait a minute. So what would it be? How many groups of 2 groups of 5 is it to make it 40? How many groups of 2 groups of 5 makes it 40? Nice. So it's 8 groups of 5, but it's only 4 groups of 2 groups of 5. Thank you so much for noticing that. Wonderful. Awesome. Yes. So here's my nudge to us as teachers. Sometimes we get concerned when we see our students drawing 258 ones, right? And we get like, oh my gosh, couldn't you just use groups of 10s, or couldn't you just use groups of 5 or whatever it is, right? Maybe you guys aren't having these feelings, but that's fine. Maybe I've had them before secretly. But I want to notice a name here, all the math that we can see that we might not be able to see or engage with if a child just wrote 43, 43, or wrote 43 plus 43 plus 43. Now, I don't want to devalue that thinking either, right? It's super valuable and we meet kids where they are. But I think it's our job really to find the glory in these models and press on them even for the whole class. I think even if the rest of my class, let's say in second or third or fourth or whatever, wasn't engaging in directly modeling by ones, this would be a super valuable share in that we're looking at groups of groups and equation work that, again, I couldn't so easily engage with in such a concrete sense-making way if I had just a numerical representation of the story. Is that making sense for you guys? Yeah. Okay, good. So I know we're running out of time here. Before we go, I do want to make a plug. This is the children's mathematics book. I call it the CGI Bible. There is a chapter in here, chapter 8, that's all about problem solving and modeling. And it really elevates this idea of modeling, I think. And in the last page, it actually has an example of 300 minus 299. And students who have experience with self-invented models, right? Student-invented models, and students who do not. And it's very interesting what appears there. So here's my plug for children's mathematics. Any questions before we hop off, or comments or ahas? What are you guys thinking? Awesome. Good to see you, Liz. Not really see you, but be in your space. Hope you're well. Awesome, Blair. Yeah. Great. Definitely. And I know you do that at TUSA, and you help others see the beauty too. Thank you for your work. Thank you.
This was beautiful. Thank you.
Yeah. You're welcome. Thank you all.